Greetings and welcome back to the module 2 of spectroscopy, types of spectroscopy. The objective of this session is to learn the various types of spectroscopy available. The outcome of the session, the learners will be able to classify or distinguish the types of spectroscopy. Before going to it, let us revise the contents which we have discussed in module 1. Number 1, we have learned the electromagnetic radiation and its types. Number 2, spectroscopy, which is a study of interaction of electromagnetic radiation with matter. During the interaction, the energy from the electromagnetic radiation is absorbed or emitted by the matter. You just keep this thing in mind to understand the module 2 in a better way. The spectroscopy are classified into two based on the interaction of electromagnetic radiation with matter. If the interaction of electromagnetic radiation is with atom, then it is called atomic spectroscopy. And the interaction of electromagnetic radiation takes place with a molecule, then it is called as molecular spectroscopy. In a simple way, atomic spectroscopy deals with the interaction of electromagnetic radiation with atom, whereas molecular spectroscopy deals with the interaction of electromagnetic radiation with molecule. The definition seems very simple, but the process of molecular spectroscopy is very complicated, because we all aware of the molecules comprises of more than one atom. In atom, one cannot expect rotational vibrational transitions, whereas electronic transition can be expected, whereas in the case of molecules you can have all rotational, vibrational and electronic energy levels, which results in the transition between the rotational, vibration and electronic energy levels. Let us see the distinctions between the atomic and molecular spectra. Spectra is a readout by the recorder after the interaction of electromagnetic radiation with atoms or molecules. Atomic spectra occurs due to the interaction of electromagnetic radiation with matter, as it was clearly explained and defined in our previous slide, which produce a line spectra because it is having only electronic transition. Whereas in the case of molecular spectra, interaction of electromagnetic radiation with molecules takes place, leads to produce a complex spectra due to the transition in vibrational, rotational and electronic energy levels which is present in a molecule. I hope it is clear between the atomic spectroscopy and molecular spectroscopy. Similarly, atomic spectra and molecular spectra. One should not get confused between the spectroscopy and spectra. Let me clarify one more time. Spectroscopy is the interaction of electromagnetic radiation with matter, whereas spectra is a readout recorded by a recorder out of the interaction of electromagnetic radiation with matter. I hope it is clear. And different types of molecular spectroscopy is available: UV visible spectroscopy, infrared spectroscopy, nuclear magnetic resonance spectroscopy, electron spin resonance spectroscopy, etc. Whereas the examples of atomic spectroscopies are flame photometry, atomic emission spectroscopy, atomic absorption spectroscopy, etc. So, in the UV visible and IR spectroscopy, NMR and ESR spectroscopy, where the interaction of electromagnetic radiation with the molecules used to take place, whereas in flame photometry, atomic absorption spectroscopy, etc., where the interaction of electromagnetic radiation with atoms used to take place. And next classification is absorption and emission spectrum. In the case of absorption and emission spectrum, here the measurement of radiation after the absorption of electromagnetic radiation by the matter is the basis for absorption spectroscopy, which can be explained with the help of the energy level diagram. The molecule M gets excited by the absorption of photons of energy h nu. The measurement of this decrease in the intensity of radiation is the basis of absorption spectrum. Whereas in the case of the another image in the right side, the excited molecule M star comes down to the ground state with the emission of photons of energy h nu, which is measured by the readout in the form of spectrum. That spectrum is called emission spectrum. So based on which we are having examples of absorption spectrum, spectroscopy and emission spectroscopy. UV visible, infrared, nuclear magnetic resonance, atomic absorption spectroscopy, etc. are the examples of absorption spectroscopy, whereas fluorimetry, flame photometry, atomic emission spectroscopy are the examples of emission spectroscopy. Here this is the second classification. They are classified based on the measurement of radiations from the matter at the recorder. Thanks for your participation. Kindly attend the online session in the Google Meet platform for any clarification if you have. The Google Meet link and the timetable will be shared through WhatsApp group. I hope the contents are very clear to you peoples Thank you very much.